So first let me discuss an example which is of the machine learning type or pattern recognition type. I'll be using a data set which is very familiar to most statisticians. It is already part of R. This is called the iris data set collected by a certain Mr. Anderson, popularized by Fisher. So it is sometimes mistakenly called Fisher's iris data, though it should be called Anderson's iris data. Now this data set consists of certain measurements of iris flowers. So here I have shown one flower. This is of one variety of iris. It is called iris setosa. And you can see that there have got petals and sepals. A rather strange kind of flower where the sepal is much longer than the petal. We are more accustomed to seeing it the other way around. So that is one type of iris, iris setosa. And here is another. This is called iris versicolor. And in this case, the petals are much larger than the sepals. And here is the yet third variety, which is called iris virginica. So the question is whether we can identify a flower, an iris flower, as either setosa or versicolor or virginica based on only the measurements of its petal and sepal. So for each such thing, petal or sepal, we have got two measurements, its length and width. So petal length, petal width, sepal length, sepal width. And based on these four measurements, we want to identify a flower as belonging to the setosa group or the versicolor or virginica. Now, a quick look through all these flowers immediately convinces you that it is a very simple exercise. So, a method that fails for iris data is a method which is just not worth anything because it is almost trivial to say which is which. So anyway, we are going to use this as our running example. So in R, we can already see that this data is there. It is called iris. So let's see the size, dimension, 150 by 5. So if I just look at the names, it will be clear what these are. Sepal length, sepal width, petal width, and the species, that is this versicolor, etc. So I will just look at the first few rows. These are all measurements and all the first 6 are setosa. In fact, there are exactly 50 setosa, 50 versicolor and 50 virginica flowers for which these measurements are available. Now suppose we have some method by which we think we can identify the species of a flower. So let's take a very simple method. Suppose my method is the following. For these things, I will take the mean value of the sepal length. I will work with only sepal length. I will take the mean value of the sepal length for each of these different species, and whenever a new flower comes to me, I will find out its sepal length and put it in that particular species to whose mean it is the closest. That is a very simple way of doing it using sepal length. And I might do the same thing using petal length. And I am interested in knowing which of these two methods is actually better. Is using sepal length a better way of distinguishing the species or petal length? I want to answer this question. That is a typical question that can be answered using cross-validation. So my first step will be, given my data set, I should be able to detect all those things. So I will start by this. So I have given some data set. I will call it data equal to iris. Later I am going to take only part of the data set, but first I am trying to understand, get a feel for it. I will isolate all the setosa flowers from it. So I will take the setosa. So what I will do is I will call it setosa is data. I will take those indices. So I will take those indices where data, I want the last column, that is 5, equal to setosa. Let's see whether this works. I execute. So let's take a look at setosa. So it's a list of trues and falses. The first 50 are true and the remaining 100 are false. Now, of course, I knew that the first 50 will be true, so I could have just made it first 50 and last 100. But later, when I am going to mix things up, this thing will help. So I do the same thing with the other two spaces. And what were the other two spaces? Let me quickly see. I raise 5. They were setosa, versicolor, and virginica. So the next one is versicolor, and this one is virginica. So this is virgin. Now I am interested in taking only the sepal length, that is the very first column. So I will take my, was that the first column? I do not remember. Names, sepal length, yes. I will give it a smaller name, SL, for sepal length. So that is my tat data first column. Just to give it a smaller name. Now I need to find out the means of the various things. So I find the means. So I will call it M setosa. I am doing it in a sort of a longhand way. It is possible to make this code much more compact, but just to show all the steps, I am doing it in this way. And this is mean of SL only for the setosa case. So this is a useful thing in R. Whenever you put a Boolean true-false array as an index, all the trues are retained and all the falses are discarded. So I take all the sepal length for setosas and I get M setosa. And I do the same thing for the other things. So M, I will do it for versicolor. M versicolor. This is also for versicolor, and this one is for virginica. Well, I needed versicolor, virginica. So I have this. Now someone is going to give me a test flower for which I need only the sepal length. So I will say new SL. So new sepal length. And what I am going to do is, I am going to see which one is it closest to. So in order to do that, I might do the following. It will help if I just put all these things in an array and quickly find out which this one is closest to. So I can write all means equal to C, M setosa, M versicolor, and M virginica. I made a list of all the means. So whenever I get a new SL, I will subtract all the means from it, take its absolute value, abs, and find its minimum. The minimum itself is not important. We need to know where the minimum occurs. So which dot min will give me that. So that will give me where it should actually land. So let me just try out my thing, except that I still do not have a new SL. So I will create a new SL and I will give it some value. So let me just see what the typical values are. So iris, first column. So I have to see that 5 is a typical value. So I suppose I give it, say, 5.31. Just giving it 2 decimal places so it does not clash with any of the already observed values. Not that there is any problem if there is a crash. And this is what I want to find. So let's quickly go through this thing. So I have my data set. I split them up. I compute the different means. I put them inside a single vector. I have my new flower. And I say which is the closest. and I see that it is 1. Remember, 1 means setosa. So this chap gets classified as setosa. If I change this, instead of this particular flower, I use something else. Suppose my new flower has 6, in that case 2. So then it classifies it as versicolor, and so on. So you understand how my particular classifier, my pattern recognizer or machine learning procedure, howsoever you call it, works. This is my proposed technique. So the first thing that I would like to do is to pack this up into a function. Now when you pack this up into a function, you will quickly notice that much of this is independent of what particular new sepal length you give. In fact, all the things up to this line, everything up to this line, that is same. The new value is required only after that. So I might as well say that I will do that part only once. I will do this part only once. And now every time you give me a new case, I will apply that particular sepal length to this particular, this array of all means. This is what is called learning or training. Arriving at this all means, that is the training part. And there is no need to do this training every time a new observation, a new test case arrives. So that is how we look at it, so that if we break it up into 2 parts, in that case that will save a lot of trouble. So I will split it in this way. So I will call it a function. Let me call it doTrain. So doTrain is a function which will take some data set, training data, and we are going to pass iris, and then this function will just, I will put everything inside that function and I will finish that function providing the all mints. So it will give me all the mints and remain prepared. Now every time I get a new value, I will write a function called doClassify. That is a function which will take the new value. And what that will do is, it will take that all means that I had. So I will put it like this, knowledge. And instead of all means, I will call it the knowledge. And it will return that. So the idea is that all means that it returns, that is the knowledge that will be used for classification. So the effect that I showed earlier can be obtained now as doTrain iris, and from that you get your knowledge, call it no, and then you pass that knowledge to doClassify whatever you know, and the new thing that you have got, say 6.21. So you have your test data, or you have your training data, the iris, then you do the training and you do that part which is common to all the recognition thing. You lump them together, do it only once. That is called training your model. When I say training your model, this model is not same as a statistician's model. By model here we mean a technique, just a recognition technique. With that thing, no, I also give you the new value and you do classify based on that knowledge. So let's just quickly carry out these things. So I will quickly load the entire stuff. Fortunately there is no error, and I will just see what is my knowledge. It corresponds to the 3 means, and then I will do classify. Well, I already have it here. And it says that it seems that it is a Virginica. You can be more fancy, you can type the name Virginica inside and all those stuff, but I will call them 1, 2, and 3. So this is one complete method, and I want to know how it performs. And similarly, you may have a different method which does the same thing but with petal length. So let's quickly write that. Pretty easy to do. So instead of calling it just do train, I will give it a name, do train SL, means training with SL. And this one I ideally do not have to change because the classification rule always remains the same. Classify it into that species for which the mean is the closest. So I will just leave it as it is. Well, maybe I will change it here also, because for this simple example it is like this. For a more complicated example, everything will be different. So that is your method 1, and here is my method 2, which does everything the same thing except that we will be working with the petal length. So I will be working with the petal length. Same. So petal length will occur in column 3. I change that. Everything else remains the same. So I will just try it. Petal length. Here I did it with sepal length. So I load it. No error. Very good. So I just run this command, and this time I classify it as 3. So if I am using a sepal length, I still have this sepal length, I should make it petal length. If I am using petal length, then also I am classifying it as 3. But if on the other hand I am using sepal length, then I am classifying it as 2, because something with petal length 6.21 and something with sepal length 6.21 need not be the same flower. Okay. Now my question is, which one is better? So the first step is, before you even ask which one is better, is to encode them in terms of 2 functions. One of them is train and the other is classify. Training part encapsulates everything which needs to be done once, and the classify part, all those things which require it to be done every time. Okay, so now we are ready to enter into the cross-validation loop. So in the cross-validation loop, we are going to take, suppose we plan to do how much? We have got 150 flowers. So I think it's a good idea to do a 10-fold cross-validation. 10-fold cross-validation, so I will take 15 flowers and call them the test set and the remaining thing as my training set. So I split them. Now you see, it's only natural that you do a stratified sampling here, because in your 15 flowers, it might happen you get only setosa. You may get only Versicolor, or they are not very evenly distributed. To ensure that distribution is proper, I would like to pick not just any 15 flowers from the entire lot. I would rather say I will pick 5 flowers from setosa, 5 from Versicolor, 5 from Virginica. Now how can you do that? And remember, we have to do it again and again inside the loop. So it will be helpful if we just do a random permutation of each of the group. So I do a random permutation. So I will do setosa rand maybe, which will be sample 50-50. That is, draw a simple random sample without replacement, by default without replacement, of size 50 from 1 to 50, basically a random permutation. Similarly, you will do for the other things. So you have Versicolor rand, that is sample 50-50, and finally Virginica. I am just writing everything in longhand. You can do things much more compact. Okay. So after you have randomized, I can just use the randomized data in the following way. So what I will do is, I will take so let's do it in this way. I will, it might help if I just split up the different things. So I will take my setosa things as iris 1 to 50. Similarly, Versicolor is also iris 51 to 100, and finally Virginica is iris 101 to 100. Then I will do the random permutation. So ideally I can just do the entire thing pretty fast by putting everything in one line. So I will now do setosa. I am going to randomize them as setosa. But now I am going to give this the random permutation. So setosa rand. Well, maybe I will just use sample 50-50 right here. That saves some typing. So ideally you do not need these things then. So I get a random permutation of them, and similarly I do the same thing with Versicolor and the same thing with Virginia. I do the same thing with Virginia. So I created my random permutation of the things. Now I will pick just the first 5 of setosa, first 5 of Versicolor, and so on. So I will take, say, I will take the first 5 of, well, I will take the, not the first 5, I will take the first 45 of setosa, and that will be my training set. So first 45 of setosa, so my train index will be 1 to 45. So my train data will be this. Train data will be setosa train index, train data. With it, I will do an R-bind. R-bind means you are taking some matrices and binding them one below others, binding them as rows. This then I have Versicolor, not train data, train index. Train index, and then Virginica train index. So I created my training data. So I've got train index, I've got train data. So let's quickly just run the entire thing to see if everything is working. I have some error. Incorrect number of dimensions, because I call this rand, so that should not be the case. Yes, now it is okay. Okay. So I now have my train data. So let's take a quick look at that. Dim train data 135, 15, 5 as it should be. 135 because out of 150 I have removed 15. That part will be my test set. So for this train index I am going to train both the things. And similarly I will going to create my test index. Test index equals, I have taken 1 to 45 there, so I will be doing 46 to 50. And then we do test data, much like the way I did there, except that all the train indices will now be replaced by test indices. Test indices. So let me just execute that. Let's check their size, test, and I've got 15. Very good. Now what I want to do is I would like to train my this, so I will do knowledge based on SL, that is do train dot SL. I will be training using the train data. Train data. So what is this knowledge that I have gained? That is basically all the means of the flowers, of the sepal lengths of the flowers included in my training data, those 135. And similarly, using the same train data, I can try PL, knowledge.pl. These are the corresponding means for sepal. No, I am again showing PL, so this should be PL. These are the things these are for the petals. Okay, so now you give me some new flower. Suppose you give me, I have my test data. So my test data, I will take the very first thing, 1. So this is the sepal length for the first test flower. So I want to see where this lands. So I will write it here. So I have got my test data 1, 1. I am doing it for sepal length first. And I want to say do classify SL. Based on the knowledge I had of SL, I want to classify this one. Now I actually know what the class should be, so I can compare that against this. I can compare it with test data 1, 5, because the fifth column stores the true spaces. I know the true spaces. I am just pretending as if I do not know to make it the test data. But now I can actually compare. So once I do that, I can see whether it has done correctly or incorrectly. So let's try it. It says false. Now this false means no, it has done a mistake. It has not been able to recognize at least this particular flower. Okay, so I can try for the next flower in my test data, and I will try this one. Again false. So this flower has also been recognized wrong. Bad thing. I hope I did this training stuff correctly. There are so many mistakes. It doesn't look very nice. Let me just see whether I have done the do classifies properly. Yes, no, these things are all done correctly. So I will just copy them here. Here. So this is also wrong. Now of course I want to do this for all the things in the test data, so I might as well run a loop for I in n row of test data, 1 colon n row, and carry this out for all the cases in a loop, I and I. And store it somewhere, res I equal to this, so res equal to numeric n row of test data. So whatever is needed to store all the results, they are all booleans, but zeros and ones, so numeric. So if I do that, in that case, I will see how these things perform. I call it res SL. So let me just do it, and I can check what is res.sl. I see 0, 0, 0, 0, 0, that is all those things are false. Something looks a bit fishy to me, I am not sure. So let me just try out the same thing for all the petal lengths. Petal length. And this time I am using 3. This is as before. and I need to allocate fresh memory here, petabytes. So I am using both the techniques. I will just check res.el. That is also all zeros. So how do I debug it? Possibly the simplest way of debugging it will be just to see where am I classifying them. So let's comment out this part. I'm curious, where am I am putting them. Well, I'm putting them in these places, and if I try test data 5, that is the problem. Okay. So here the problem is that they are encoding it as 1, 2, 3, etc. And I am encoding it as, but the original data encodes them as Setosa, Versicolor, Virginica, and things like that. So I just need to change them to the corresponding numbers. I think the best way to do it is right at the beginning. Instead of working with that general thing, I might work with by replacing in my original data that thing. So I will start with my iris data, wherever I had my iris data. So I might do this. Iris equal to iris 5 equal to C rep 150. So the first things I am making them equal to 50, then the remaining thing I am making them 2s, and then the third thing I'll make them 3. So if I do that, then that will encode everything as 1, 2, 3. And here I will just check it against 1, 2, and 3. Same thing is to be done here also. 1, 2, 3. And then everything should be okay. Let me just see if they're okay or not. So I have executed everything, and I will see what are my test data 5. They are now 1s and 0, 1, 2s and 3s. So I will remove this comment. And then, right, so now it is much more reasonable. I see 1, 1, 0, 1. 1 means it's correctly classified, 0 means it is wrongly classified. Similarly for PL, I have many more false classifications. So from this, we naturally say that sepal length is actually a better distinguishing variable than petal length is. Now here I used one particular training set and one particular test set. You might like to vary that as well. That's what people will do. So they will put this entire thing inside a big loop. So for k in 1 to, we did a 10-fold cross validation, 1 to 10. And then train index will not be always 1 to 45. They will pick only that part which will be included in the training index. So you just have to do some jugglery with the indices. I am not going to go into that. This is already a long session. And similarly, the remaining thing will go into the training session. And then you run the entire thing. So the entire thing will be run say 10 times, and you will average out their performances and see which one performs better, and accordingly you will pick that one. So that is how you use cross-validation for carrying out selection of techniques in the pattern recognition setup.